Assalamualaikum warahmatullahi wabarakatuh. We are group 26. My name is Fiza Shazaliana binti Muhammad Supian. My teammates are Nur Najwa and Desitra. We are going to present our project titled Bone Type Recognition. We are going to discuss about problem background, methodology, program codes, output, and conclusion. Problem backgrounds. Accurate identification and classification of bone types from X-ray images are crucial in the medical and forensic fields. However, this process traditionally relies heavily on manual examination by the specialist, which can be time-consuming, prone to human error, and dependent on expert availability. The advancement of digital imaging technologies enables the development of intelligent systems that can pre-process medical images, extract critical features, and accurately classify bone types. Therefore, this project aims to design an automated bone touch recognition system using image processing techniques to enhance diagnostic efficiency. To achieve this, the project focused on enhancing image quality through pre-processing techniques, extracting and analyzing key feature bone structures using pattern recognition methods, and implementing an intelligent classification models. Methodology. There are four types methods that we use in this project, which are Gaussian noise filtering, enhancement power law transformation gamma, segmentation edge detection Kenny operation, and morphological operation. Morphological operation can be split into two, which are closing operation and skeletonization.
Assalamualaikum, my name is Nur Najwa and I'm going to continue about methodology. So here we have start, then we input. We have the pre-processing stage of the image, noise removal, segmentation, morphological operation, and the output. Next is the program codes. I prepare the data pre-processing code. And here, first, we prepare the data set. The data set have 5 types, which is femur bone, humerus bone, patella, tibia, and ulna. So we find all that and prepare the data set like this. Here we have the folder, bone recognition data set. And then we look through each image file and read the image using this YAML because we want to know all of the image that we prepared. And for the pre-processing, first we display the original image here, and then we convert it into the grayscale. If the images have color, they have simulate noisy conditions by adding Gaussian noise. This is just for the testing. And then we have the window filtering, which is good for Gaussian noise to remove noise. Then we resize the image to 256 times 256 pixels. It's to uniform size for all images. And we enhance contrast using a mathematical transformation here. Then we improve the brightness and contrast further using gamma adjustment. Gamma equals to 0.4 and we save the final file enhanced image to the new folder.
This is the program codes that implement by me. First of all, convert the RGB image to grayscale image using RGB to gray and resize the image to 256 times 256 pixel for image processing. Second, apply Gaussian filter to reduce noise while keeping the edge and result smoothest image. And third, enhance the image with zero point 0.4 gamma correction to adjust brightness and contrast of the image. Since the value is less than 1, then the dark areas will become brighter. Fourth, detect the edge using Kenny. Why Kenny? Because Kenny combines multiple steps including noise reduction, smoothing, and edge shaping, and sensitive to strong gradient change in both directions. So it can highlight the geometric line and sharp boundaries. Fifth, use this shape element with radius 2 for closing operation which close the gaps and fills the internal holes while keep the area with the region more than 500. We use the this shape element because the shape is non-linear. And the last one, extract bone center lines using skeletonization while preserving the overall structure and connectivity. That's all from me. Thank you.
Hi, I'm Desitra, and I will be presenting about the feature extraction process. So the feature extraction is done using the area, eccentricity, and perimeter using region props. And then the valued IX is used to filter the region with area bigger than 2000 and eccentricity bigger than 0.5, and then to select the largest valid bone area to detect the most possible bones. And then for this part, before the parameter, area, and eccentricity circularity computed, the value region is detected first to find the one with the largest area, which is this part. The bone orientation is then detected if the aspect ratio is less than 1. The bone orientation is horizontal, otherwise it shows vertical. Is in this part. So before that, to extract the features, we need to use the formula to detect the perimeter, circularity, and also the bounding box, as well as the aspect ratio. And then the code shows the new figure to show the pipeline of the processing of all the X-ray image, which is this part. So this is the figure, and the title is Bone Detection of the X-ray Images Pipeline. So this will be all the pipeline of the X-ray image. We shows the subplot 221 shows the gamma corrected X-ray image, 222 Kenny H X-ray image, 223 morphological process, and subplot 224 shows the detected bone approximately with box with Gaussian filtered image. This shows that the bounding box is used to detect the bone in the box region of red and the title bone detected in yellow. So this will be the extracted features part. It will bring the extracted features of area, eccentricity, and circularity first, and then it will detect the possibility of the bone based on the area. If let's say the area lies within 6,900 to 14,000, then it's possibly detected as tibia or femur, and it goes on for other possible bones. But the bone detected is using the area only. So this will be the output for the testing images of the pre-processed one. So this will be the gamma cross X-ray image, scanning age, morphological process, and the detected bone with the box. So it shows the bone orientation is vertical, extracted features will be the area, eccentricity, and circularity, and the predicted possibly bone is patella or ulna. So the original image of the bone is actually patella, and it is predicted properly based on the area, eccentricity, and circularity. And then this will be the another output based on the preprocessed image testing as well. So this will be gamma, canny, morphological process and detected. So this will be the extracted features and is possibly detected as an ulna or humerus or femur. So the original image is actually a femur and it is detected properly in possibility of femur. Now I will go through the demo part. So this will be our pre-processing code. So first will be the original folder, then the output folder. The original folder is our dataset, and the output folder is after the pre-processed dataset. So this root directory is to reach each of the images format for pre-processing, and then we use Gaussian noise filter, and then linear filtering, and then resize the image. After resizing, we use this formula for contrast stretching. After that, we use gamma correction for enhancing the X-ray images, which gamma equals to 0.4. And then the pre-processed image is saved in the output folder. So let's go to the prediction. So let's say we want to test image. When I run, I get this output. So this is the gamma corrected X-ray image, canny age X-ray image, morphological process, and detected bone within the area. And then the bone orientation detected is vertical. Extracted features 27213.00 pixels, eccentricity, circularity, and the possibly detected bone is ulna, humerus, or femur. As I said, this bone I uploaded is actually a humerus, so it possibly detected properly. So let's say if I upload an image. So this will be the output image, gamma corrected X-ray image, canny is X-ray image morphological process, and the detected bone within the area. And this will be the extracted features with its bone orientation, it's vertical. The area is 17222.00 pixel, the eccentricity and circularity, and possibility detect bones of femur or tibia. So the possibility is correct since the uploaded image is actually a tibia. So that's all for the demo part. Okay, so now for the conclusion. In this project, the bone type recognition from X-ray images is successfully demonstrated by using image processing techniques. So we have gained understanding of images as notch removal, segmentation, and morphological operation. And we discovered that these functions are so important in image processing. The advantage of this recognition system is it reduces manual work and human error, and as it automatically recognizes the bone type. While the disadvantages of the system is that the accuracy can be affected if the image is poor in quality. And the constraint we faced while working on this project is we found difficulty in finding high quality X-ray images which are labeled because medical images are often restricted. And this is the reference that we have. And that's all from us. Thank you.